Okay, so we're going to be thinking about energy changes in chemical reactions. So let's imagine that you're at home and you are cooking some pasta. So you've got your pan of pasta with some water in it, and then you've got your stove and you're using gas to heat that up. Okay, so let's think about what the chemical reaction is that's happening here. All right, so the gas that comes out of your stove that's burning is a gas called methane. And that reacts with the air and it burns. So it's reacting in the air with oxygen. So that's what's happening whenever you use gas to cook anything. Okay, and it's the same that we use in the lab with the Bunsen burner. Okay, so the gas is methane and it's burning with oxygen to produce this flame, which is hot. All right. So we know that that produces heat. It also produces two other chemicals, which are water and carbon dioxide. Now, the water and the carbon dioxide, they're both produced as gases, and that's why you can't see them. All right, but they're there. So it's we should by now be able to understand that this is a chemical reaction and this is the change that's happening. But we want to think specifically about the changes, the energy changes, because we know that this is getting hot because we use it to warm up our pasta. All right, so let's think about the reactants. Okay, now we can imagine the amount of energy the reactants have is like the energy in a battery. Now it isn't a battery, it's just like a battery. That's a picture of a battery. Now we might suppose that inside the methane and the oxygen we have this much energy. All right, quite a lot. All right. Now, in our products, we've also got an amount of energy. All right, and that amount of energy might be, again, similar to a battery. It's not a battery though, but it's just similar. We're thinking about it in those terms. Might be this much energy. Okay, so what we can see is that the level of the energy in the reactants is quite high, and the level of the energy in the products is lower. Okay, so what's happened is, during our reaction, the amount of energy in the chemicals has decreased. Okay, now we know that energy can't be created or destroyed, so the question is, where has this extra bit of energy gone? This bit here, where's that gone? All right, and the answer is that that energy goes into the surroundings. Like this. Okay, so some of that energy, so remember this energy, the energy inside the chemicals has decreased. So that extra bit of energy must have gone somewhere. Some of it has gone into the water to heat the pasta. Some of it will have gone into the air around the cooker. All right, so obviously when you're stood there cooking your pasta, all right, not only is the water getting warm, but you stood in front of it will also be getting warm as well. So we have a special name for this kind of chemical reaction, and that is exothermic. All right, and so we can say a few different things about an exothermic reaction. Number one, okay, so we can see that here the chemical energy is lower in the products than it is in the reactants. So the chemical energy in the products lower than in the reactants. That's the first thing that we can say. And we can see that here we had a lot of chemical energy in our reactants and then less chemical energy in our products. The second thing that we can say about an exothermic reaction is what we see up here. Okay, so the energy that has disappeared from the chemicals must go somewhere, and it goes into the surroundings. So we can say that energy is released into the surroundings. Okay, and that's why we do this chemical reaction to heat our pasta, because the energy that's released into the surroundings can be used by us to warm the water which cooks our pasta. All right, and number three, the third thing we can say is, if I was to put a thermometer into my pan of pasta, that's a thermometer, I would observe in this thermometer the temperature increasing. Obviously, because the exothermic reaction is releasing energy into the surroundings. Okay, so it's releasing energy into the water's getting hotter, and the temperature will increase. So for an exothermic reaction, the temperature of the surroundings increases. Okay, so let's think now about a different type of reaction. So let's think about photosynthesis. Okay, now photosynthesis is the process by which plants make their own food, and that happens by the reaction of carbon dioxide plus water to give glucose and oxygen. Now we can do the same sort of analysis as we did before. So we can look at the reactants and we can think, well, how much energy is going to be in our chemical energy store of our reactants? Again, think about it like the energy stored in a battery. All right, there's about this much. And then, if we think about the energy stored in our products, well, you should be thinking to yourself, I know that this is food for plants. Okay? So you would expect there to be lots of energy stored inside your glucose. Okay? Lots of chemical energy. All right? Because the plant is going to need to use that in order to grow. And glucose is sugar, and you know that if you need energy, you can go and eat a spoonful of sugar and you'll have lots of energy because there's lots of chemical energy in glucose. So, if we were to draw that out in the same way, we would have a higher level of energy in our products. So, you can see that the opposite has happened now in our reaction. So the amount of energy stored in the chemicals has increased. It has increased, but we know that energy cannot be destroyed or created. So the chemical reaction can't make energy. So this extra bit of energy here that we've got, this extra bit here, where has that come from? It can't have just magically appeared out of nowhere. It must have come from somewhere. And the answer is that it comes from the surroundings. Okay, so it comes from the surroundings. Okay, the opposite to our exothermic reaction, where energy is released into the surroundings, Now we have energy coming from the surroundings into the reaction. All right, and we have a special name for this kind of reaction, and it is endothermic. So we can also say a few things about endothermic reactions. Number one, we can see that the chemical energy in the products is now higher than the chemical energy in the reactants. In the reactants. And number two, we can see that in order for the energy to be higher in the reactants, higher than it is here, that energy must have come from somewhere, and it is absorbed from the surroundings. So energy is absorbed from the surroundings. Okay, and let's imagine that we have here a thermometer, and energy is being, the thermometer is in the surroundings, and energy is being taken out of the surroundings. So what's going to happen to the temperature on our thermometer? Well, because energy is being taken away from it, the temperature on the thermometer is going to go down. So our third thing is the temperature of the surroundings decreases. Okay, and that's something you might have to think about a little bit, because we're very used to this idea of chemical reactions producing energy. So when we think about chemical reactions, we always think about things burning or things exploding, that kind of thing, and they produce lots of energy. But there is another type of chemical reaction that we don't see as often, called endothermic, where the temperature actually decreases and things get colder. Okay, now sometimes these will get applications in things like sports packs for injuries. So you might have seen those where you can initiate the sports pack and it will start to get colder, and you can put that on an injury to keep it cool and stop the swelling. So that's an application of this kind of reaction. So those are the two different types of energy changes that you need to know about for chemical reactions: exothermic and endothermic. So I would recommend on a flashcard giving yourself exothermic reactions, and then the three different points that I've made here about exothermic reactions, because you need to know all of these different things. You need to know about the relative amount of energy, you need to know about the direction that the energy moves in, and the temperature. Okay?